All right, in this video, we are going to discuss the different production technologies that are available for firms to use to help create a process strategy. We've been talking about how we can improve our processes through continuous improvement, the technologies that are available, some of the process analysis and design tools to really make a process that matches our organizational competitive advantage. And so in this lecture recording, we're going to talk about some of the production technology that is available. And essentially what we're talking about is equipment and technology that has helped to make processes more efficient, have shorter lead times, higher quality, reduce costs. These are all good things that we want to incorporate into our processes because ultimately that's going to benefit our customer. And when our customers are happy, they are theoretically going to be reoccurring customers for us. And so on the back end, on the operational side, anything we can do to improve our operations and our processes is a good thing. So the use of production technology will help us in achieving that goal. So when we look at various production technologies, really what we're trying to accomplish is keeping our costs low, but really trying to get a competitive advantage through having flexibility. That's the ability to respond to our customer demands with little penalty in time, cost, or customer value. And so some of the various production technologies that are out there are machine technology, automatic identification systems, process control, vision systems, robots, automated systems, flexible manufacturing systems, and computer integrated manufacturing. So we're going to talk about all of these in the next couple slides. So the first one is just machine technology, capital equipment, different things that are out there to help us do our jobs. And machine technology comes into play a lot in manufacturing. So what I've shown on the screen is you can see these top right three pictures are all printed circuit board assembly machines. These are the pieces of equipment that I've spent the most of my manufacturing career surrounded by. And they were great for increasing precision, productivity, flexibility, reducing errors, reducing lead times, and they just really helped improve throughput and improve quality. Machines don't need to take breaks. They don't need to go home and sleep at night. They can run continuously. So machines have helped us, especially in manufacturing settings, to reduce errors and be more productive. If you look at the bottom left-hand picture, this individual is placing an electronic component, it's either a capacitor or a resistor, onto a printed circuit board, and this is called a printed circuit board assembly. And so if you don't use machine technology, you're literally using your hand, and you're soldering these electronic components onto a printed circuit board assembly. It's very time consuming, it's very error prone. And so one of the analysis that I used to do was that whole make or buy analysis to determine if machines were going to be a good investment for my organization or not, or if we should still just have manual labor who is soldering these electronic components onto the printed circuit board assembly. So these machines are for printed circuit board assemblies. I used to call them pick and place machines because they very quickly have little robotic arms that go down, grab the electronic components that are needed, they move that little arm, and then they immediately populate them onto the printed circuit board assembly, versus a person who's using tweezers, placing it onto the printed circuit board, and then soldering it by hand onto that piece of that assembly. So machines have been great. There's lots of other examples out there besides printed circuit board assemblies, but that's what I've chosen because that was my world for a decade. And so machines are great for precision, productivity, flexibility, and reducing costs. Next is automated identification systems. These help us to transform data into an electronic form. So for example, barcodes. They help to improve data acquisition, reduce data entry errors, increase speed. So if you think about just a barcode and how simple or how for granted we take barcodes these days. If you rewind many, many years ago before barcodes were available, if you used to go to the supermarket and you bought 20 items, that grocery store clerk had to manually type in the cost for every single one of those that produce or whatever it is that you were buying. So, lettuce, okay, $3.99. Tomato, $2.99. And just go down the list, and they would manually type in everything. So a barcode has dramatically improved that time to get you out of that grocery store, just because now they're scanning everything. And like we talked about in the last video, you can improve throughput for your organization because now that's all done. You can do it by yourself. You don't even need to go to that checkout clerk anymore. You can do it yourself. You just scan everything. And so that's been a big process improvement for grocery stores. RFID, or radio frequency identification, is a wireless system in which integrated circuits with antennas send radio waves. And so this is still kind of in trial and error phase, having this done in grocery stores as well. I know that Amazon is demoing it with some Whole Foods and things like that. But hopefully someday, 5-10 years from now, I can just walk into a grocery store, put stuff in a cart, and then walk out and not even have to go through the process of scanning the barcodes anymore, because there'll be RFID on all those products, and I can just walk straight out the door, and then they just send me the bill. So that'd be pretty neat. But RFID is used in various other applications, especially in logistics, so supply chain and logistics, to let people know where their packages are as of today and where they are in that supply chain logistical journey, moving from point A to point B to point C, so people know where those products are located. All right, next is process control. This helps with real-time monitoring and controlling of processes. It's the use of information technology to set a physical process, or to control a physical process. So you can see the guy at the bottom of the screen. He's sitting in a room, and if you pay close attention, you can see he's in an Anheuser-Busch facility. So he's manufacturing beer. But you don't see, if you look at his computer screens, you don't see actually any beer. What you see is a process control that he's monitoring. So whether he's doing statistical process control, or he's monitoring the maintenance of equipment, making sure that the inputs and the outputs are all accurate, looking at various sensors that collect data, whatever it may be, he is essentially running a process from a computer screen. So that is an example of process control, where computer programs are analyzing data, and you've got people who are monitoring processes remotely to make sure that they are running smoothly. An example of this would be, I work in a hospital setting, so there are many of times when I go into a hospital lab and there's a maintenance person working on an analyzer. And I can be talking with the lab director, and he or she will say, I didn't even know something was going wrong with that analyzer. I didn't know it was out of calibration. They showed up this morning because they just knew that their process was getting out of control, and so they sent a tech proactively to come and adjust it to make sure it's working correctly. So it's kind of like the sensors that you have in your car that tell you when you need to get an oil change or when your tire pressure is low. The same thing happens with capital equipment, various machines, analyzers, whatever it may be, that someone who is not on site can tell if that process is working correctly, and then they can make those corrective adjustments going forward. So that's process control. Next would be vision systems. These are systems that use video cameras and computer technology in inspection roles, so mostly in inspection roles. It helps because a lot of these high volume manufacturing facilities where your outputs are hundreds of parts per second, these vision systems can take really quick snapshots to see, is everything that's coming off that production line the quality that it's supposed to be? And why there isn't, vision systems just like the machines and some of these process technologies that are available in robots. Vision systems don't get bored. They don't get tired. They don't need smoke breaks. So, imagine if your job was to work in inspection for a high volume facility, and like this picture on the top left shows, that looks like hamburger buns, I think. Maybe they're donuts, I can't tell. But either way, at this commercial bakery, that finished product is probably coming off the production line relatively fast. And if your job is an inspection and you're just sitting there staring at an assembly line all day long to make sure that the output is meeting your quality requirements, you're going to get very bored very fast, and mistakes are going to happen. So vision systems are great because they can automatically, they're automated, and they're going to tell you based off of different parameters if your product and your process are in control. So Lots of different tools for vision systems. They can be used in manufacturing, like to see if there's the right amount of sealant. They can be used like on a Frito-Lay assembly line to make sure that there's no imperfections in the chips and that they're the right weight. You can see another example on the bottom is scanners are used so that you can check to see if there's yolk inside of eggs. So vision systems are a very handy tool, especially for inspection. The next machine technology or production technology that we'll talk about is robots. You've all heard of robots and how they're taking over the world. Well, they're not, but they do have a place, and that's for sure. So a robot is a flexible machine with the ability to hold, move, grab items. It functions through electronic impulses that activate motors and switches. They're great for performing monotonous or dangerous tasks. They help to perform tasks requiring significant strength or endurance, and they're great because they're consistent and they're accurate. And so you can see the two examples on the screen are robots. The one on the left is welding a car together. You need to get the frame and the chassis and the doors and all those things welded together, and so robots are great for that. And then there's another robot on the bottom right that's also doing some welding task. And one thing you notice about both of these pictures, and I didn't even do it intentionally, but there are sparks flying everywhere for this task. And that's an employee safety improvement. If you think about an employee used to sit there and weld all of this together, they can get hurt pretty easily doing these kind of dangerous tasks. I've got a cousin who works in welding in Tennessee, and he's always getting hurt. So, robots are great for a manufacturing line where it's a mundane, monotonous task where it's just the same thing over and over again. A robot would work perfectly for that. Another example of a robot that didn't do welding, but great for holding and moving large pieces of equipment or boxes around. When I worked in manufacturing and I had the shipping department reporting into me, literally one of my oldest employees, he'd been at the firm for 50, 60 years, he worked in shipping. And his job was to put our 50-pound plus power supplies into a cardboard box, put all the foam or the packaging or the bubble wrap or whatever it is that we used, and then he would package it up and he would ship it to our customers. And he'd been there for a long time, and that was his day-to-day role. Dude, what we made was heavy. And so this guy was literally physically picking things up off an assembly line, moving it over to a different shelf to where he could store things. Then he'd move them to a table where he could wrap them, and then he would place them on the ground on a pallet, and then that pallet would eventually get shipped to our customers. But he was doing all of this by hand. And I'm surprised he never got hurt. So I bought him a little robot that helped him go down and grab these very expensive and very heavy power supplies, pick them up, and place them into the cardboard box. So he still manned that robot, but he was now no longer picking up 50-pound power supplies 30 times a day and moving them around physically. So all that to say, the risk of him getting injured was mitigated by having a robot help him in his task. So he loved it. He loved it. So robots can help assist in functions like that as well. All right, next would be automated systems. Automated systems can be either an automated storage and retrieval system, which is on the top right, or automated guided vehicles on the bottom left. Automated storage and retrieval systems are becoming more and more common, especially in these massive distribution centers like you have with Walmart or Amazon, where you just see rows and rows of shelves stacked miles high of products and boxes. And what you don't see is individuals, people walking down these aisles getting those boxes. It's all done by computer-controlled automatic machines that are taking them off of the shelves and bringing them to the shipping location where they can then be shipped to the final customer. So it's all automated. Things are stored in automated locations, and they're retrieved or pulled and brought out of that facility, and it's all done automatically. Someone or some computer is inputting the order, and then the a computer system is going to go and grab that part and bring it to where it needs to go. So the inventory is delivered to you. You don't have to go get it yourself. I think one of the videos that I posted in either supply chain management or for process strategies shows the little itty-bitty robots. They kind of look like Roombas that go around these facilities and grab the packages at an Amazon warehouse, and how they bring them from their automated storage and retrieval system in that warehouse to the shipping location. And so it's all done by these little robots and these automated systems. Down below is an automated guided vehicle. It's an electronically guided and controlled cart used to move materials. It's great for moving products, heavy products, to their final location. But you can also have robots or automated guided vehicles that don't move heavy stuff. They just move stuff so that people don't have to walk all around facilities, and which is a non-value added activity. So if you recall from that spaghetti diagram that I showed a couple of videos ago, sometimes you can't reduce the distance between one location and another. So an example of this would be when I go to a hospital laboratory, you can't change where that hospital laboratory is and where the individuals are getting their blood drawn or their surgeries performed. So I was at one hospital, and I work in healthcare, so you just got to get used to talking about all these terrible things that happen to people, but you also got to get used to seeing blood and body parts everywhere. So I was in a lab and I couldn't help but laugh, but here comes like a little R2-D2 robot, and he's got a tray, and he's got vials of blood on that tray. And so little R2-D2 is just walking around with blood on a tray, but what he was doing was he was taking it to its final location. So whether it was the chemistry analyzer or hematology or microbiology, he was taking blood and body parts on a little tray to where they needed to go. So instead of having a person physically walking around delivering these testing samples to the analyzers, they had a robot do it. So it was an automated guided vehicle. They called him Henry. He had a name. They put stickers on him, and he was part of the family. So Henry was an automated guided vehicle, and it was super efficient for them. Okay, next is flexible manufacturing systems. These are systems that use an automated work cell controlled by electronic signals from a common centralized computer system. And so the key here is that it's computer controlled, and they make changes easily. The operators can simply load new programs so they can make different kinds of products. Flexible manufacturing systems are great because they bridge the gap between product focus and process focused facilities. And it really helps to reduce waste and improve flexibility, which is why they're called flexible manufacturing systems, because they're super agile and changes can be made quickly. It's all computer controlled and done electronically. So there's very little human interaction in this type of manufacturing system. Okay, and then the last production technology we'll talk about is computer integrated manufacturing, or CIM. This really takes a whole bunch of production technology and combines them all together between AutoCAD or computer-aided design, computer-aided manufacturing, which is CAM, those automated storage and retrieval systems and automated guided vehicles. You're taking all of these together and you're putting them together, and it's great if you've got the capital and to set up an extremely sophisticated system like this. It's used for warehousing and for shipping, so from start of process to design to the finish and shipment of goods. It's an extension of flexible manufacturing systems. It goes backwards to engineering and inventory control, and then it goes forward to warehousing and shipping. So again, it really helps to reduce the distinction between low volume, high mix, and high volume, low mix type of production facilities, because so much of it is computer aided in that manufacturing process. But you've got to have a lot of capital to be able to do so, because they are extensive systems. Okay, so examples of technology's impact on services. I could literally spend a half an hour talking about how all the improvements we've been able to make in services because of technology, but I won't. I will spare you. I do want to bring up a couple examples just because this slide got me thinking. It's always fun for me to think about this slide and think about all the improvements in technology and the improvements I've seen in my lifetime, and I'm not that old. So, I think back to when I was in college. We had pagers. I had to go to a computer lab. I didn't have a personal cell phone. And we didn't have the internet. And if we did, it was dial-up. And so just thinking about all the dramatic changes that have been made since I graduated college in 2000 versus now, this list just keeps getting longer and longer every single year of all the impacts, the technological impacts that we've made to improve the productivity and the customer satisfaction of our services. Think about financial services. In the last video, I talked about how I've got a private banker that I can talk to when I want. But I've also got on my phone, E-Trade, Coinbase, Merrill Lynch. I can do things all by myself just on my phone, and I don't have to talk to anybody if I don't want to. That's a great technological improvement. For education, depending on the semester, I might have hundreds of students. Well, when I teach this class in person, I use a thing called the iClicker. So students who are sitting there physically in class use a clicker for the quizzes. And those quizzes are automatically graded because I put the right and the wrong answer into a portal. And then once the students are done, their grades are automatically populated into Canvas. Turn it in is a great feature for me as an instructor, because when people turn in papers, it literally tells me which website they copied and pasted from, or which fellow student they copied and pasted from. And so now we know which students are plagiarizing and which ones aren't, and it does it all electronically for me. You guys are taking this class on Canvas and listening to this lecture recording. That's all done by technology. The quizzes, I put in there the right and the wrong answers, and it grades it right there for me, so I don't have to do any of that. So that's all technological improvements. Healthcare. I'm helping a client right now buy $1 million piece of robotic equipment to do surgeries. And I don't know how I feel about that yet, to be honest. But they swear by it, that for some surgeries, robots do a better job than a surgeon. And so they're going to spend $1 million on a piece of equipment because it's better for the patient and it will help them in their long-term costs because they won't have a surgeon performing that surgery. When my children were born, they had an RFID tag on their ankle. And if we left the hallway on a little walk and we went a little too far away from our room, alarms went nuts. They would shut down the elevators, they would lock all the doors so you couldn't walk away with our kid. So that's a technological improvement. They've got little locks, or not LifeLock, but LoJack. It's baby LoJack because of RFID. So anyway, I can go on and on about all the technological improvements that have been made to services. So just think through, some of these improvements, how they've impacted your life, how they've made your life better, or maybe worse. I don't know. But there are so many examples that how technology has improved service productivity and customer satisfaction. Okay, now let's talk about process redesign. This can also be called process re-engineering. This is really just taking a fundamental rethinking of business processes that bring about dramatic improvements in performance. We need to look at why we're doing a process and how we can do it better. It's really just focusing on the key activities within that process and which ones add value and which ones do not. Any process is a candidate for redesign. And like we've talked about through lean process improvement, continuous process improvement, Kaizen events are a great tool for mapping out a process to see which ones could be re-engineered. So you look at every single step in that process. Whether you create a flow chart or whether you use Post-it notes on a wall, it doesn't matter. Kaizen events help you to identify which steps in the process could be either eliminated or improved, or you can add technology to help make that process more efficient going forward. Okay, so that wraps up this video on production technologies that are available to help us improve productivity, throughput, reduce costs, and improve customer satisfaction. So hopefully you can think about some of the technologies that are out there and available and maybe either suggest them or propose them as opportunities in your workplace with your employer to make those kind of process improvements and redesign the current processes that you have today.